Great. Hello, everyone. Today I have the Chapter 5 study guide. It's a pretty long one, so let me just jump right into it. So our first one here is number 1. It just says solve the system by the substitution method. We have x plus 3y equals -2, and then 5x plus 4y is equal to -10. So the first thing I'm going to do, so I'm able to actually sub one of these into each other. So I'm going to make the first one equal to one variable. So since x doesn't have a coefficient, I'll make it equal to x. So we have x plus 3y is equal to -2. I'm just going to minus 3y on both sides. So I get x is equal to -3y minus 2. And now that's something that I can plug into my second equation right here. So now I have 5 times -3y minus 2 plus 4y is equal to -10. Distribute the 5 out. I get -15y minus 10 plus 4y equals -10. I'm going to add 10 on both sides to move over my -10 on the left. And then I'll combine both my y terms. So I get -11y is equal to 0. Well, in that case, if I divide both sides by 11, I get that y is equal to 0. Then I can plug it back into whatever one I'll choose. I'll take the top one. So I'll say x plus 3y is equal to -2. So if I plug in my 0 for y, I get that x is equal to -2. So I'd write that as my solution is -2, 0. Moving on to number 2, it's a similar problem. They still want us to use substitution, except now we have to deal with a little bit of fractions. But since they're both equal to y, I can just sub one y into the other, so I can make them equal to each other. So I can say that 2 over 5x minus 17 is equal to 1 over 6x minus 10. To get rid of the fractions, I'm going to multiply them by their least common denominator. So in this case, it's probably 5 times 6, which is equal to 30. So you end up multiplying each side, basically everything in the problem, by 30. So on this side, 30 divided by 5 is 6. So I'm going to 6 left on the top. So 6 times 2 is 12. 12x minus. And then 17 times 30 gets you 510. That is equal to same thing. So it's just 30 divided by 6 on this side. That just gets you 5. So I get 5x. And then 10 times 30 is 300. I'm going to add 510 on both sides. And I'm also going to minus 5x on both sides. So we get that 7x is equal to 210. So if I divide by 7x, I get that x is equal to 30. Once again, I'll just plug that into my top equation. So my y equals 1 over 6x minus 10. If I plug in 30 for that, I get y is equal to 5 minus 10, or in that case, y is equal to -5. So my solution for this one is 30, -5. Moving down to number 3, they ask us to use a different method. They now ask us to use the addition/elimination method. So in this one, we have -3x plus 5y is equal to -18. Yours, I already crossed it out, but I think it says 17. I think that's an error. I could not get the answer given. So I think it should be a -18 for what the first equation is equal to. So -3x plus 5y is equal to -18. And then it's also 5x minus 4y is equal to 17. So the first thing I want to do is I want to get one of the variables to have the same coefficients but with opposite signs so that they can eliminate. I always try to pick the one that gives me the smallest numbers. So in that case, it would be with the x. I'd multiply the top equation by 5. and the bottom equation by 3. So in that case, my equations change to negative 15x plus 25y equals, that ends up being 18 times 19, or 18 times 5 is a negative 90. And my bottom one, it will also be 15x. It'll be minus 12y, and that's equal to 51. So adding down, as I wanted my x's cancel, 25 minus 12 is equal to 13, so 13y. And then negative 90 plus 50 is negative 39. Divided by 13 on both sides, I get that y is equal to negative 3. And I'll just once again plug back into my top equation. So negative 3x plus 5y is equal to negative 18. So I get negative 3x minus 15 is equal to negative 18. Add 15, add 15. Negative 3x is equal to negative 3. So dividing by negative 3 on both sides, I get that x is equal to 1. So that makes my solution 1 comma negative 3. All right, on to 4. This one says that you can use any method. The easiest way that I saw to solve this one was to just sub in. So since 1 is already equal to y, I'm just going to sub that y into the other. So this gets me 4x plus 12 minus 4x is equal to 11. But you can see what happens here. My 4x is actually canceled because it's 4x minus 4x. So I can just cross those out. And I end up getting 12 is equal to 11, which isn't true. So this one has no solution. All right, moving down on to 5. I don't have the question right now, but I can read it. It says the Family Arts Center charges $22 per adult and $10 per senior citizen for its performances. On an evening when 549 people paid admission, the total receipts were $7,698. How many who paid were senior citizens? So whenever you're setting up these word problems where it's a system of equations, always look for what they're asking you to solve, and that will tell you what your variables have to be. So in this case, they're asking how many paid that were senior citizens. So in that case, like how many senior citizens bought tickets. So you're solving for the amount of senior citizens. I'm also going to assign the adults a variable since I'll need them for my question. So x is equal to, I'll say the adults, and y is equal to my seniors. So it says that in total, 549 people paid admission. So that's one of the easier equations to get. Well, then that means that there was x adults plus y seniors, and their total was 549. And then the other one will just be what your ticket price is. So 22 times x represents the adult tickets. 10 times y represents the senior tickets. And that's equal to the total amount they made, 7,698. So now this one looks easiest to solve by the elimination method. I just have to make one of the coefficients equal. The easiest one to do that with is with the y's because it's the smaller number. So I'm just going to multiply my top equation that I made by negative 10. So placing it below it, it's negative 10x minus 10y equal to negative 5,490. So then adding them together, I get 12x. My y's cancel, and that is equal to 2,208. Divide both sides by 12. I get that x is equal to 184. Then I'll just plug into my easier equation to solve for my one that goes for the total amount of tickets sold. So x plus y is equal to 549. So that means 184 plus y is equal to 549. minus 184, minus 184. I get that y is equal to 365. So this is important to make sure what is the question asking you for. Don't just right away put, oh, well, I have my x and y, it's 184, 365. That is not the answer. They're looking for how many senior tickets or how many senior citizens paid, how many senior citizen tickets were sold. So since we said y is equal to our seniors, we are only looking for the y as our answer. And usually these should be put as like a word answer. So 365 seniors paid. All right, moving on down to number 6. It's a similar one. We'll have to set up the equations. So it says Cassandra purchased tickets to an air show for 8 adults and 2 children. The total cost was $210. The cost of a children's ticket was $5 less than the cost of an adult ticket. Find the price of an adult's ticket and a child's ticket. All right, so I'm going to say X is equal to the child ticket and Y is equal to the adult ticket. Because then just making sure they are asking for the adult and the child's tickets, how many of them or what the price of it. So this is actually, let me be more specific. This should be price of child. Price of child's ticket. We're not finding the price of children. And then price of adult ticket. All right, so the first one says that 8 adult tickets and 2 children tickets added up to $210. So that's going to be 2x, that represents the 2 child tickets, plus 8y is equal to 210. Then the next one says the cost of a child's ticket was $5 less than the cost of an adult's ticket. So there's 2 ways you can write that. I'm going to choose to say, well, if y is the price of the adult ticket, that means x plus 5 is the cost of it. Because it would be the child's ticket and then 5 less. So you could say y minus 5 is equal to x, but I'm going to go with this case. So this one looks easiest to solve by substitution by just subbing in my y from my bottom one to my top. So solving that, I get 2x plus 8 times x plus 5. So distributing the 8, I get 2x plus 8x plus 40 is equal to 210. So 10x is equal to, if I minus 40 on both sides, I get 170. Divided by 10, divide by 10, x is equal to 17. Then I'm going to plug into my second equation. It's probably the easier one. So y equals x plus 5. So y equals 17 plus 5. So y equals 22. So what do these values mean? Well, we'll go back to what we assigned them. My x is the price of the child's ticket. My y is the price of the adult. So it's $17 for a child ticket and 22 for adult. That is number 6. Moving down to number 7, this one has a few parts to it. This is using the cost, revenue, and profit functions. So part A, well, let me read the question first. It says, Anne May owns a business marketing and selling jackets, or business making and selling jackets. She has a fixed cost of $2,400. It costs $73 to produce each jacket, and the selling price of each jacket is $103. So part A is asking you to write the cost function and the revenue function. So for the cost and revenue, for the cost, you just add up all the costs, and for the revenue, you add up all the revenue. So for C, to label the cost function, our fixed cost, no matter what, maybe that could mean like owning the shop, paying rent, is $2,400. It is also $73 more for each jacket she makes. So I'll say plus 73. And since it's jackets, I'll make the variable J. For my revenue function, it is strictly going to be her profit from the jackets or her selling price, which would be 103 per jacket. So 103J. That's part A. Part B, it says determine the number of jackets that must be made and sold in order to break even. To solve that one, you're going to equal your newly made revenue and cost functions together. So we'll just say R equals C, or 103J is equal to 2,400 plus 73J. So if I minus 73J on both sides, I get 30J is equal to 2,400 divided by 30. J equals 80. Ooh, let me redo my pen. J equals 80. So to write it out, you need to sell 8 jackets. Oh, my pen is not starting to like the Word doc. There we go. All right. So part C is now asking, write and simplify the profit function. So for the profit function, that is equal to revenue minus cost. So then my profit, plugging in my revenue function of 103J minus the cost, 24,000 minus or plus 73J. So distributing the negative, I get 103J minus 24,000 minus 73J. So simplifying, it ends up being 30J minus 24,000. That is your profit function. And the last part I'll write over here, part D. It is just asking you how many jackets does the owner need to sell to have a profit of 36,000. So we'll just use our equation we just made, plug in 36,000, or not 36,000, 3,600 for P, and solve for J. 3,600 is equal to 30J minus 2,400. All right, so adding 2,400 on both sides, we get that 6,000 is equal to 30J. Divide by 30. We get that J is equal to 200. So what does that represent? You have to sell 200 jackets to make $3,600. All right, down to number 8. It says Steve invests in a circus. The cost includes an overhead of 8,000 of 80,000 plus production costs of 5,000 per performance. A sold out performance brings in $15,000. Find the number of sold out performances X needed to break even. So the first thing I'm going to make for this one is my cost and revenue function. So my cost, it'll include that general cost fee, which they say is 80,000. And then added is the $5,000 cost per performance. So I'll say 5,000X. And then my revenue, that's just going to be strictly how much I make for my sold out performances, and that's 15,000X. So then now I have to equal those together. So I'll say 15,000X is equal to 80,000 plus 5,000X. minusing 5,000x on both sides. I get that 10,000x is equal to 80,000. Divide by 10,000. I get that x is equal to 8. So in terms, what this means is that you need 8 sold out performances to break even. All right, moving on to number 9, one of my favorite kind of problems because they're long. 3 different systems of equations. So what you have to do for these is just a bunch of addition and eliminations. Whenever I start these, I look for the easiest variable to eliminate first. Usually one that either has all the same coefficients, one that might take as not much multiplying to make them all have the same coefficients. In this case, this one would be z, because 2 of them are already matching. So in that case, I just have to combine the 2 that already aren't matched, or combine the 2 that already are matching. And then I'll just have to multiply one of them by 4 to be able to cancel with the bottom one. So I'm going to combine the first 2 equations, since those 2 don't require any multiplication to get rid of z. So I'll just rewrite them. 4x plus 3y plus z is equal to 2. And then 5x minus 2y minus z is equal to 13. This is kind of a weird tip, but I know this is something that really messed me up before. Now that we're starting to use z a lot more, if you do have an issue with your z's and your 2's, put a line in your z's. I learned that I used to always mix it up and think my z's were 2's. So if you put a line through it, that kind of represents in math the letter z. All right, so just adding down, I get 9x plus y. My z's cancel, and that's equal to 15. For the next 2, I'm going to multiply the middle equation by 4, so that it cancels with the 4z on the bottom. So just multiplying it out, I get 20x minus 8y minus 4z is equal to 52. The other one stays the same. So then adding these together, I get 23x minus 7y. My z's cancel, and that's equal to 67. 67. So now to combine these 2 equations, I'm going to multiply the first one that I found by 7 so that my y's cancel. So I'll multiply by 7, and I'm going to put it right below it. So I get 63x plus 7y is equal to 105. And then adding down, I get 86x. My y's cancel is equal to 172. Dividing by 86 on both sides, I get that x is equal to 2. So now I'm just going to plug back into this equation to solve for y. So 9x plus y is equal to 15. So 9 times 2 plus y is equal to 15. So 18 plus y minus 18 minus 18. I get that y is equal to -3. And then for my last one, I think the easiest in my mind to plug into is this middle one here. So 5 times 2 minus 2 times -3 minus z is equal to 13. So I get 10 plus 6 minus z equals 13 minus the 10 minus the 6 on both sides. I get that -z is equal to a -3. So divided by -1, z is equal to 3. So that makes my solution 2, -3, 3. All right, number 10 is a little bit easier because one of them is missing your variable. In that case, since the middle one's missing a y, that can't be the one of the variables that you keep, because in that case, once you get to the second step, you can't move on from there. So in that case, I'm going to add the first and third equation together to eliminate the y. Before I can do that, though, I'll have to multiply the top equation by 3 just so that my y's will cancel. So I'm going to do that and put it up below. So I get 3x minus 3y plus 9z is equal to 15. And then adding that together, I get 4x, my y's cancel, plus 10z is equal to 20. So now I'm just looking at the middle equation here. 3x plus z equals 2. And then now my new one I just got, 4x plus 10z equals 20. So to combine those together, I'll need to eliminate one of the variables. I'm going to multiply my second equation here by a negative 10 so that my z's cancel. So I get minus 30x minus 10z equals negative 20. Adding those together, I get negative 26x, my z's cancel, is equal to 0. So in that case, that tells me that x is equal to 0. Plugging into the middle equation, the 3x plus z equals 2. 3 times 0 plus z equals 2. So in that case, my z equals 2. And then probably the easiest one to plug into is the top one. So I'll say x minus y plus 3z is equal to 5. So 0 minus y plus 3 times 2. Negative y plus 6 is equal to 5. Minus 6 minus 6. Negative y is equal to negative 1. Divided by negative 1. Y is equal to 1. So my solution for this one is 0, 1, 2. All right, moving on to 11, they're just asking you to set this up. This is a pretty big paragraph. So it says, Ron attends a cocktail party. He wants to limit his food intake to 117 grams of protein, 100 grams of fat, and 100 grams of carbohydrates. According to the health conditions hostess, the marinated mushroom caps have 3 grams of protein, 5 grams of fat, 9 grams of carbohydrates. Spiced meatballs have 14 grams of protein, 7 grams of fat, and 15 grams of carbohydrates. And the deviled eggs have 13 grams of protein, 15 grams of fat, and 6 grams of carbohydrates. How many of each snack can he eat to obtain his goal? The only sentence that really matters right now is how many of each snack can he eat to obtain his goal? So that means the names of the snacks are going to be our variables. So I'm going to let x equal the mushrooms. Y is equal to the meatballs. And z is equal to the eggs, deviled eggs. And then since our types of snacks are variables, the types of, I guess, I don't even know what those are called. I'm not a science major. Proteins, carbohydrates, and fats. Those are going to be each one of our equations. So one equation is going to relate to protein, one equation is going to relate to fat, and the other is going to relate to carbohydrates. So I'll just kind of write across. So there's 3 grams of protein in the mushroom, so I'm going to write 3x. Then there's 14 grams of protein in the meatball, so I'll write times 4 or plus 14y. And then 13 in the deviled egg, so it's going to be plus 13z. And the total amount of protein he can have is 117. So that's your first equation. So now I kind of repeat the process for the next. So with regards to fat, there's 5 in the mushrooms, 7 in the meatballs, and 15 in the deviled eggs. And that has to equal 100. Then the next one, there's 9 grams of carbohydrates in the mushrooms, 15 in the meatballs, and 6 in the deviled eggs. and that has to equal 150. And that is your system of equations. For number 12, it is very similar. Now it says a deli sells 3 sizes of chicken sandwiches. The small sandwich contains 6 ounces of meat and sells for $2.50. The regular chicken sandwich contains 10 ounces of meat and sells for $3. And the large chicken sandwich contains 12 ounces of meat and sells for $3.50. A customer requests a selection of each sides for reception. She and the manager agree on the combination of 44 sandwiches made from 24 pounds, 8 ounces of chicken for a total of $126. How many of each sandwich will be in this combination? And it also gives you the conversion of 1 pound to 16 ounces. So since it's asking for how many of each size of sandwich, that is my variable. So I'm going to say X is equal to the small sandwiches, Y to the regular, and Z to the large. I'm also going to do a quick calculation. I'm going to figure out how many ounces in total it is instead of in pounds and ounces. So if it's 24 pounds and 8 ounces and there's 16 ounces in a pound, I'm going to do 24 times 16 plus 8. And this ends up equaling 392. So then I'll make my first equation in regards to the ounces. So there's 6 ounces in the small sandwich, so I'll write 6x. 10 ounces in the regular, so 10y. And 12 in the large, so I'll write 12z. And that has to equal my 392 that I just got. The next one will be in regards to money, or the price of them. So it's 2.5 for the small, 2.5x, 3 for the regular, and 3.5 for the large. And that has to equal 126. And then the last one, it might be a little bit hidden, but you just have to add up our variables, and they have to equal 44, because it has to be 44 total sandwiches. So my last one is just going to be X plus Y plus Z is equal to 44. And those are my 3 equations. All right. Going down to 13, it is asking you to solve this system by the substitution method. X plus Y is equal to 9, and then Y is equal to X squared minus 14X plus 49. So I'm just going to sub my Y right from the bottom one into the top. So I get X plus X squared minus 14X plus 49 is equal to 9. I'm going to minus over the 9 and add together my like terms. So simplifying it, I get X squared minus 13X plus 40 is equal to 0. Now I'm going to have to factor this a little bit to solve for 0, or when in doubt, plug it into the quadratic formula. But I always prefer to factor it. So I need something that multiplies to 40, that adds up to negative 13. And that ends up being negative 8 and negative 5. So I get X squared minus 8X minus 5X plus 40 is equal to 0. So X parentheses X minus 8 minus 5 parentheses X minus 8. So I get X minus 5 times X minus 8. So that tells me that X is equal to 5 and that X is equal to 8. Plugging into the top equation with my X equals 5, I get 5 plus Y equals 9. Or minusing 5 on both sides, I get that Y is equal to 4. Doing the same thing with 8, minusing 8 on both sides, I get that Y is equal to 1. So my 2 solutions are 5, 4, and then also 8, 1. For number 14, we get that. Let me move over to it. It's saying that y is equal to x minus 1 and that y squared is equal to negative 4x. We're still using the method of substitution, which honestly is the easier method here. Plugging in my bottom equation, or my top equation really to my bottom, I'll get that x minus 1 squared is equal to negative 4x. I'm going to write this out so that I can double distribute. So I get that x squared minus 2x plus 1 is equal to negative 4x. So adding that 4x over, I get that x squared plus 2x plus 1 is equal to 0. I can show it, but something that adds to 1 that adds to 2 is obviously 1 and 1. So I get that x squared plus x plus x plus 1 is equal to 0. Pulling out an x on the left and a 1 on the right. I get x plus 1, x plus 1. So that tells me that x equals negative 1. And then just plugging into my top equation, I get that y is equal to negative 1 minus 1. So y is equal to negative 2. And that makes my solution negative 1 comma negative 2. All right, down to number 15. We get that 2x squared plus y squared equals 4 and 2x squared minus y squared equals 4. And they ask us to use by the substitution, or not by substitution, by the addition method. Well, the coefficients of y squared are already opposites of each other, so I can just add them together. So I get 4x squared is equal to 8 dividing by 4. I get x squared is equal to 2. Taking the square root of both sides, I get x is equal to plus or minus the square root of 2. Make sure you don't forget that plus or minus, because that's going to give you more solutions later on. So for when x equals the square root of 2, I'll plug it into the top equation. So 2 parentheses square root of 2 squared plus y squared is equal to 4. So that gives me 2 times 2 plus y squared is equal to 4. 4 plus y squared is equal to 4 minus 4 minus 4. Y squared is equal to 0. Taking the square root, I get y is equal to 0. Then I'll also go through the process of plugging in x equals negative square root of 2. However, just to save me some time, I'm not going to draw out all the math because you end up getting the same thing after step 1. Since it's a negative squared, you still get 2 times 2 plus y squared is equal to 4. So doing the same math, you'd end up getting y is also equal to 0. So your two solutions are square root of 2 comma 0 and negative square root of 2 comma 0. Don't just assume that you're going to get the same answer. Definitely go through the process and plug it in. But in the cases where it has like the x squared, the positive and negative don't really matter at all. All right, on to number 16. They're asking us to use the same addition method, but we have 3x squared minus 2y squared equals negative 6. And 5x squared plus 4y squared is equal to 56. For this one, we have to multiply a little bit so that we can cancel things out. I'm going to multiply the top equation by 2 and put it below it. So 6x squared minus 4y squared is equal to negative 12. So I get 11x squared is equal to 44. Dividing by 11. X squared is equal to 4. Taking the square root, x is equal to plus or minus 2. For x equals 2, I'll plug it into the top equation. So 3 parentheses 2 squared minus 2y squared is equal to negative 6. So I get 3 times 4 is equal to, or minus 2y squared is equal to negative 6. 12 minus 2y squared is equal to negative 6 minus 12 minus 12. I get negative 2y squared is equal to negative 18 divided by negative 2. I get y squared is equal to 9. take square root, y is equal to plus or minus 3. Do not assume that this always happens, but for plugging in x equals -2, you get the same answers. X, and you get 3 times 4 minus 2y squared equals -6. Dot, 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 dot. Y is equal to plus or minus 3. So you actually have 3 different solutions for this one. You have 2 comma 3, 2 comma -3, -2 comma 3, and -2 comma -3. Those are all your solutions for this one. All right, on to number 17, we start graphing. So it's asking us to graph the solution set of the system and indicate if a solution has no solution, if a system has no solution. So my first one is 4x minus y is less than or equal to -4, and x plus 2y is greater than or equal to 4. So for these, I'm going to want to make it look like something that's easier for me to graph. In that case, usually getting y alone on one side. As for my top one, 4x minus y is less than or equal to -4. I'm going to add y and add 4 on both sides. So I get that y is greater than or equal to 4x plus 4. For my other one, x plus 2y is greater than or equal to 4. I'm going to minus the x over. So I get 2y is greater than or equal to -x plus 4, and then divide by 2. So I get y is greater than or equal to -1/2 x plus 2. All right, and throwing together a quick graph. 1, 2, 3, 4. So my first one is y is greater than or equal to 4x plus 4. I'll draw that with red. So starting at 4, go up 4 over 1. You can also go backwards as well as if you want. But it'll look something like this. It is solid because it's greater than or equal to. And since it's greater than or equal to, you shade above the line. For my other one, I'll make it blue. Blue. So it's start at 2. And you go down 1 over 2. Down 1 over 2, over 2, over 2. Up 1 over 2. Up 1 over 2. So it'll look something like this. And since it's greater than, it is also up. So then you can see where they overlap. I'll make it purple. This is your solution. Like the top left section of the graph. All right, moving on to the next one. We have y is greater than x squared and 10x plus 2y is equal to, or less than or equal to 20. I'm going to make the bottom one a little bit simpler. The first one's already has y alone, so that one's perfect. I'm going to divide everything by 2. So I get 5x plus y is less than or equal to 20, or sorry, 10. So then if I minus 5x on both sides, I get y is less than or equal to -5x plus 10. So now I can graph both of these. Should be like 10. Bottom really doesn't matter. So for my first one, it is just a parabola that starts at 0, 0. So 0, up 1 over 1, then up to 2, 4. You can tell where that is, like about there. and then 3, 9. Like there. And remember, this one is dotted because it is just a greater than sign. Then my other one, it starts at 10. My blue. Starts at 10 and then goes over 1, down 5. 1, 2, 3, 4, 5. So something like that. And this one is solid because it's a less than or equal to sign. And I did forget the shade. So for my parabola, it says that y is greater than, so I'll shade up above the line. And for my other one, it's less than, so I'll shade down. Should keep shading all the way down. So my place that overlaps, which is going to be purple, is this middle section right here. All right. Down to number 19. This one gives us 3 different ones. So we have x plus 4y is greater than or equal to -4. X is greater than -4, and y is less than or equal to 6. So just moving around this top one, that should be 4y. Greater than or equal to -4. Minus the x over 4y is greater than or equal to -x minus 4. And then divide by 4. So y is greater than or equal to -1/4 x minus 1. Have a lot of room for this graph. 1, 2, 3, 4, 5, 6. 1, 2, 3. All right, so for my actual graph one, that's a line, I guess a linear line, I should say. It starts at -1, and it's going to go down 1 over 4, down 1 over 4, up 1 over 4, up 1 over 4. So it looks something like this. It is solid because it is greater than or equal to. And I'm going to shade up because it's greater than or equal to. For my next one, I'll do my my x is greater than -4. So it's going to be an up and down line at x equals -4, and it'll be dotted because it is a greater than sign. And then since it's greater than, I go for all the values or shade the side that has values greater than -4. So I'll be to the right. My next one, I'll make green. And that is y is less than or equal to 6. That's going to be a line at y equals 6. It's solid because it's less than or equal to. And I'll shade down because that includes the values less than 6. Right, and then with my purple still, you can see the section where they all intersect. It's going to be this middle section here. All right, on to the last two. For number 20, we get a circle in this one. So just writing down some of the main features of this circle. It has a center of 0, 0 and a radius of 9. And then a quick little mix around on my bottom one. If I add x squared on both sides, I get that y is greater than x squared. And now I can graph. So the first one I'll do is my circle. So this one I'll just have to put, well, it's at 0, 0, so I can put that one. But then I'll have to go out 9 sides. 10, 9, 20, 9, 29, 29. This is not going to be a pretty circle. And then since it's greater than this circle, I'm going to have to go like you would shade on the outside. So this will kind of look like a little bit of a sun for a little bit. The next one is just similar to one that we graphed before. It's a parabola that starts at 0, 0. And it'll do that up 1 over 1, then up to 4, 2, then up to 9, 3. And it keeps going. And this one, remember, it is dotted because it is a greater than sign. And since it is greater than, it will shade up. So that gives us our section kind of in the middle here. And that will be your solution for that one. And moving down to the last one, we have a little bit of kind of more serious circles. Just writing down the features. I'm going to do both of them at the same time. They both have a center of -5, -2. The top one has a radius of 4, and the bottom one has a radius of 6. So they both have that center of -5, -2. So 1, 2, 3, 4, 5. 1, 2, about like right here. My first one's radius 4. So 1, 2, 3, 4. 1, 2, 3, 4. I was kind of making them look like circles. So that's the first one. Since it's less than, let me go back actually. Let me erase this. It is a dotted. Let me erase. All right, so it is dotted since they are both less thans. And it's less than, so you shade the inside and just fill in the circle. Then the one around it is just a size of 2 radius bigger. Also dotted. But it is also shaded inward. So the only place you get that overlapping is that middle circle. So your middle circle is actually your entire solution set here. All right, that is it for the review. If you have any questions, feel free to email or like comment on the announcement that I make. But other than that, good luck on your test, and I'll see you there.